Hello and welcome to another episode of Things on Thursdays, where I look at using Redis with IoT devices or other hardware or sort of more lower level stuff than you might normally see us talking about on stream here. My name's Simon Prickett. This is episode, I think, 5 in this particular IoT project. And what we're doing at the minute is building out a sort of streaming data system. We're using Raspberry Pi Pico W, so the tiny little microcontrollers. I have one here. We're using those with a number of sensors. These are what are called Intel Grove sensors. So they have these standard connectors. So the Pi Pico here is connected to what's called a shield that adapts it to talk to these sensors. And we're writing code on here in MicroPython. We're then sending data from these devices up to Redis in the cloud, and we're using Redis streams and Redis JSON. So we're storing data in a stream, sort of an append-only log of what happened and when, as well as JSON documents, which sort of represent other things about the data and the current state of play. And what we're modeling is a sort of hotel, or it could be a warehouse, or any sort of building that has large numbers of areas or rooms. And we're modeling temperature and light and humidity values from those. And we have some other metadata about them that we're storing in the JSON documents. So what you saw me doing last week, if you saw last week's stream, and if you didn't, it's on our YouTube channel. So go ahead and find that on there. Links down below. If you saw last week's stream, what you'll have seen is that I added the ability to search some of those JSON documents. So we have temperature, humidity, light values pouring in from sensors. Those end up in JSON documents as well as the stream. And then I can, using Redis search, ask the JSON documents questions like, find me all the rooms that the temperature is between this value and that value, and where it's dark or where it's too humid or something like that. And what we're going to try and do today is, so far this has all been about data gathering. We're going to try and wrap up this project today by looking a little bit at how we can use a second Pi Pico W and some other bits of the Intel Grove kit that I have in order to send data back to the room, if you like. And what we're hopefully going to do is display the temperature that the room sensor says is the temperature in the room. So we'll have that go through Redis and come back down to a sensor that's acting as a display. And then we'll have that have some sort of cloud control of the air conditioning system. So we'll model that with a really simple fan. We'll have a cooling only version. And we'll say if the temperature hits a certain amount, we aim to turn on the fan or the air conditioning for a while. So before we do any of that, I thought I'd better just sort of run over what sort of architecture we've built so far and how it all fits together. So I'm just going to see if we can start a couple of things here. And let's do, sorry, I'm aiming to, here we go, hopefully share my desktop. Yay. Start an iPad drawing. So what we've got so far, what have we built is essentially we've got a little device down here. So a Raspberry Pi Pico W. It has a couple of sensors attached to it. So it has a temperature, humidity, and a light sensor. And what that's doing is up here in the cloud, we are running a Redis database. So there's our database, and what's happening is every so often the sensor is broadcasting data into a Redis stream. So we have a sort of append-only log that's time-stamped of temperature, humidity, and light values, and the stream gives it an ID, and that's the timestamp that we received it. So we've got that so far. And then what have we got actually processing that? So also this down here is in Python. It's actually MicroPython, a special Python that runs on microcontrollers. This up here is in the cloud is just Redis. And then what have we got else going on? We have got a consumer here that is in Node.js. It could be in anything. And it's reading from that stream. And it's doing a couple of things. So it is parsing data out of that stream. And then it is putting data back into Redis in the cloud, as we use a different color for these. JSON documents. So we have a Node.js component that's writing back to Redis. It's writing JSON documents. And what I did in the last stream was defined a search index over these JSON documents using Redis search. That's something that Redis manages for us. So we can then use tools such as, we could use any programming language, but I was using Redis Insight, or you could use the CLI. And I was writing queries against these documents and receiving results back. So that's what we've got so far. What I want to do is amend this so that we have some sort of feedback loop. So this diagram is going to get a little bit busy, but what I want to do is have the node code update JSON and also update a list in Redis, which is slightly different from a stream, and we'll look at that. And then I want to have a second Pico W down here that is reading from that list. And it's going to do two things. It's a terrible drawing of a fan. It's going to turn on a fan, so simulate cooling, and it's going to display a temperature on a display. So we're going to have some sort of loop where we start with the Pi Pico over here. It sends things into Redis. The node consumer reads them, updates JSON documents. We're not particularly going to use the search functionality. The aim of these streams isn't to build out a complete application, but I just wanted to show that you can build a search function. So if we wanted to build something like a dashboard for the hotel or the building that says, give me all the rooms that are over temperature and too humid, or where the lights have been left on for too long, we can absolutely do that. And then I want to have this sensor down here essentially poll this list and say, well, okay, what's going on? What do I need to do? Update my temperature display. And if the temperature is above a certain amount, we're going to tell it to turn on the fan for a certain amount of time. So that's what we're aiming to do today. Whether we'll get it done remains to be seen, but I shall just quit this because sharing the iPad is a little bit resource hungry. And I'll put it down to buy some desk space. So yeah, that's what we're aiming to do. We have a couple of Redis University courses, as ever. There are Redis University courses for most of the things that we talk about on stream here. We have RU204 here. This is a course about storing, querying, and indexing JSON at speed. That basically means Redis search and Redis JSON. So what I was working with in the stream last week. And then we have a course for Redis streams, which is the streams data type that we're using to ingest all of the data on this project. So those are available at Redis University. They're all free and online, and you can get a certificate and put it on your LinkedIn profile if you're successful with the course. So here's what we have. We have a couple of these Pico Ws. W means Wi-Fi. Which is great because we don't have to mess around with adding extra network capabilities. It's just built into the board. So we're using those to make adding sensors more convenient. We're using a Grove Shield, which just gives us these plug-in things. So this is the Pi with the Grove, and this is the temperature and humidity sensor, and this is the light sensor. I've actually got as well, if I bring camera 2 on there, that's the second one that we're hopefully going to get working today. It's the exact same device. It's running a MicroPython runtime. It's got a Grove Shield. The USB cable there is connecting it to power and my laptop so we can push code onto it from VS Code. And as you can see, it's got a little little display here. I'm hoping this shows up on the camera. It's actually super bright when it's on. And we've got a motor with a sort of fan. So we're not going to achieve much actual cooling of the environment in here using that fan, but the aim is to show that we can turn on or control a device remotely according to what's going on in the world. So yeah, we have both of those, and we have a code base that I've been working on here. I will pop the URL for that up now. This code base is split into the MicroPython component, which is currently only the code for the stream producer. So the temperature, humidity, light thing that just pushes data into the stream every few seconds. And the node code, which is the bit that runs, well, it could run in the cloud. It's running on my laptop at the minute and connecting to the cloud, but basically it's the server component, the bit that manipulates the stream data and creates JSON documents for us. So what we're going to try and do today is add some more MicroPython, add another component for what we'll call the thermostat. So this second Pi Pico down there that has the motor and the display connected to it. So if you want to follow along with the code, it's there, and I will push updates to it after this live stream. So shortly after this, I'll update the README and probably have to restructure it a bit based on what we do today. So I've got the Redis database up here. I won't go through everything we've got in here, but basically we've got a stream of data that has temperature, humidity, and light values. Those are all numbers. The temperatures are in Celsius. And it's timestamped, and we have a sensor ID. And we only have one sensor pushing these in, so it's sensor ID 1. Then we have a number of rooms. So in each area or room that sensors could be in, we have a JSON document, and that describes what's going on in the room. So we have some metadata, the room number. I decided how many windows was maybe interesting, a brief description that we can do full text search on with Redis search. When it was last updated, the node code as of last week's stream manages that for us. And then it also pushes in these values, temperature, humidity, and light. I've added an over temperature count as well. So what we're going to do is start counting how many readings come in that are over a given temperature that we're going to determine is too hot. And that's going to be sort of our trigger for turning on the fan down there on the other Pi. So what I can do now is if I go turn on the, let's look at the stream first. So let's turn on the auto refresh here in Redis Insight, and let's see if we can make this a little bit bigger. It's a bit of a battle with sharing the screen. And what you see is there's nothing happening at the minute. The last data we had here was the 26th of October. But if I plug in this Pico to a power source, which I've got just behind me, then hopefully it will boot up and start creating data for us. So that is plugged in and switched on. So let's see if anything happens in a few seconds when it boots up. All being well, there we go, this 27th of October, it started. So it's now 24.9 Celsius in the room here, 25, about 50-something% humidity, and that's whatever the light number is. It's quite dark here today. It's been raining all day. So we've got data coming into the stream. We've got 88 entries, and that's going up about one every couple of seconds because this thing's reporting the temperature very aggressively. We obviously wouldn't do that in production. This is just for fun, to make something happen quickly while we're watching it. So what we need to do is, I've got the code base here. It's split into MicroPython and Node. So I'm going to go into Node for the minute and open that up. And of course, it's opened off screen. That's better. So let's make this a little bit more legible on stream as well. There we go. Okay, so quick review of what we've got in the node code. We connect to Redis with some secrets. We have a a memo field that stores the last ID of what we saw in the stream. So we pick up processing from there if we're restarted, or like now, if we turn it off for a week and come back to stream another day. If that wasn't set, we start from the stream at the start. And then this code just basically sits in this while true loop, tries to read from the stream. If it finds something, it does some work, which is sort of down here, and it updates the JSON document. And it also uses a sorted set in Redis to work out which room the sensor's in. So it maps the sensor ID to a room number. We covered that on a previous stream, so I won't go into exactly how that works, but it's quite fun. So what we need to do down here is we're updating the JSON document with the new values. We're storing the last updated and the new temperature and all of that stuff. So here we now need to see if we are over temperature. So we're going to have a temperature that's determined to be too hot. And if we're over that, then we are going to do something about it. What did I call that field? I think I called it, I need to go back here to find the room that this sensor's in. Let's close that a minute. There we go, 214. We called it over underscore temp underscore count. So and the way I actually want to update that is increment it. So what we're going to do is we're going to say this over temp count that is currently at 0 here, if it reaches a certain amount, so many consecutive readings from this temperature sensor have been over our maximum that we want the room to be at, then we're going to do something. So we need to count this, and we'll say the maximum is, say, 10, and we'll say the highest allowed temperature is like 24 degrees. So what we want to do is have a look at what the value of the temperature is. So we've got that kicking around somewhere. So we want if, actually I'm using it up here. So let's create let's reuse this. I'm not doing it again. So temperature, we should be able to then just say temperature like that. Okay. So now we can say if temperature is greater than, we'll say 24 is our trigger value. Actually, I can probably address the temperature in this room a little bit by putting my finger over the temperature sensor. So let's see what the ambient temperature in this room is at the minute. 24.3. So let's say 25, and we'll see if we can so if temperature is greater than 25, then we want to do something. We want to increment the over temperature count here. So the over temperature count is inside my JSON document, inside here, and it's in climate, and it's a numeric value. So the way we access JSON document entries is we use a JSON path. So this will be $ for the root, .climate, .over temperature count, and we want to increment it by 1. So if we go look at SIO commands, let's figure out how we do that. We want, let's see, JSON commands, and we want to increment something. So here's what we want. We want to increment something that's a numeric value by another value, and it'll do that atomically. So this looks like what we want, and what do we get back? We get the new value for each path. Okay, so we can send in multiple paths. We only need one though, so we need a JSON path that does this then. So num increby. So in Node.js, which is what we're using here, that's just basically await client.json.num increby. There it is. And then we need the key prefix. So let's call this room key for now. And then we need a path, which is going to be $.climate.over, I call it over temp count. And then we need, I guess, a number, so 1. And then we need put that, and let's log it for the moment. Right, so we'll see what comes back from there. And I also need to create this. So we've already used this up here a couple of times. So let's just create a constant for it, and key prefix room ID. Let's do that. And I'm going to need it in some other places. So there, and we're going to need it right down there. Okay, so that's going to set my over temperature count. So let's see how that goes for us. So all we're doing at the minute is just setting it and looking at the new value. We're not actually doing anything yet. So what I can do is save that out and then run this. So it's called consumer.js, and let's see what happens. Hello, over temp count is now nothing. What's going on here? So what is going on here? Client.json.num increby room key $.climate.over temp count and then 1. So first off, let's check what's in the database. I think I can see what the problem is. So that value has actually gone away. And that's because we're setting the whole of climate here to be this whole object. So what we need to do is actually do this backwards. Hadn't really thought of that, but that's okay. So we just need to move that around. So move that there and save that. And then what we need to do is go back into the database and add in an over temp count field. So this is like standing data, over temp count. I need to quote it and 0. Okay, so climate's now got that again in room 214. Our code has been changed around a little bit so that we do this. That's still not going to work actually, because this is gonna overwrite all of these. This is going to overwrite the entire climate document. So what I'm going to do is just simplify this and put it in the root of the document. But I don't have to then just refactor all of this code to do separate writes. So I'm going to do over temp count in the root of the document, and I'm going to move it in my sample document here, over temp count to 0. Yep. And take one out of climate because we are kind of overwriting that. Okay, so we've now got that. We've now got over temp count in there. We've now got, let's check that everything adds up. We've got code that increments that number at $over temp count and should print it out. Okay. Run it again and see what happens. Okay, so over temp count. As you can see, it's now doing what we thought. It's incrementing itself. So 4, 5, 6, so on every time. Because at the minute, all of these are over 25. So we are over temperature. So what we need to then do is take some action when it hits a certain value. So let's just comment what this does as well. Okay, the last updated date. Right, and then for good measure, I'm going to bank this in GitHub just in case we have to come back to it. Save that just in case. Right, so we've got this value here. Over temp count is now whatever. And let's say if over temp count is 10, so if we basically had this happen 10 consecutive times that we're over the temperature, we're going to take some action. So first off, we need to reset the over temperature count so that it goes back to 0 and nothing. We start counting again, so we don't just constantly take action. And we need to then tell the other sensor that we need to turn things on, but we're building sort of quite a loosely coupled architecture here. So we're not going to actually talk to the sensor at all. What we're going to do is put something in a Redis list that we're going to use like a sort of job queue and have that sensor poll that queue and go, there's something else to do. I should do that now. So if the over temperature count is 10, what we first need to do is client.json. Let's just do set room key, and then we need that path again. So the over temperature count, set it to 0. So every 10th time through this, we're going to set it to 0. And then what we also need to do is account for the case where the temperature has actually dropped below the trigger amount. And we also need to set it to 0. So if temperature goes below the amount, then we just stop this whole counting things and start again. So once the temperature builds up, it has to hit 10 consecutive times before we take any action. So let's just be a bit lazy and we can say temperature went below the trigger point. So reset the counter. Let's reset the counter. Okay, so let's just run that. And let's just put in some logging so we can see what we're doing. Make sure this works. Okay. So hopefully when we run that, what we'll see is something. And what we're seeing is a lot of errors. So over temp count is not defined. What have we done here? So over temp count is not defined. Line 70. What have we done? Oh, okay. Oh, yeah. The variable's called new over temp count. That would be better, wouldn't it? Okay. So let's try with that. We're going through things. That doesn't seem to be to be working for us. Interesting. So let's see what we've got in the database. Over temp count. Yep, that's definitely becoming quite a large integer. Oh, I see. We were above 10. We were above our trigger point because we were messing around with the data beforehand. So what I need to do is set this to 0. Or I could change the code to be above 10, but we'll set this to 0. And hopefully it'll now go 1 through 10. And then if the temperature is still too high, which it should be, it will reset itself. Okay, and there, oh, I see what happened. So in our data stream, look, it started counting up, it got to 6 and 7, and then we actually hit, this is old data from the other day. We hit some old data where it was actually below 25, so it reset to 0. So yeah, it seems to be working. Okay, I will take that. And push it. Right. So what we need to do then is, now we've got something where we reset the count, we need to actually tell another sensor, go turn your fan on. And what I wanted to do was have that, give that sensor like a bit of information to display on the LCD that it's got. So we'll tell it what the current temperature is, because it doesn't have a temperature sensor. The other one is just a thermostat type control unit. It has a fan and a display. It's sort of distinct from the temperature sensor. And what we'll do is we will send it the temperature to display on the display. We'll tell it whether to turn the fan on. Well, we'll tell it to turn the fan on, and we'll tell it how long to turn the fan on for. So after that time, we'll have it just turn the fan off, and it'll either get subsequent instructions to turn the fan on again, or it won't. So what we're going to do here is use a Redis list. So we can use a list a bit like a job queue, and I can sort of demonstrate how that can work really quickly. So let's see if I've got Redis running here. So if we do clean out my local Redis database, this isn't the cloud one that's got the data in it. And if I want a list, then I can do something like this. I can do list push, and I can do some list, and then do an element. So an element can be a string value. So I can, for example, send in, let's say, temperature 22.2. Let's say fan. We want them to run the fan for like 3 time units to try and resolve this temperature issue. And then I can close out my JSON there, and that's gone into the list. So one of the cool things with Redis is we don't need to create things like this. So I just push something into a list key that doesn't exist, and now I've got a list with that one thing in it, and that one thing's a JSON document. So I can ask it some questions, like I can say, ln how many things are in the list, and there's one of them. I can do lpop some list, which will basically pull the thing off the front of the list, or I can do r, in which case I've got a stack, or I can do rpop some list, which will pull it off of the other end of the list, in which case I've got sort of a queue type thing, and that's what we want. So if I do that, I get my value back. And then if I say how many things are in the list, there aren't any. And then if I rpop some list again, there's nothing there anymore. So we kind of want this behavior, but a little bit different. So there's a blocking version of some of the list commands, and I'm going to need 2 Redis CLI instances for that. So over here, I can basically say blocking right pop, so pull something off the bottom of the list, some list, and then you can give it a timeout in seconds. So I'm going to do 0, which is infinity, because I need to come over here and type some other stuff. So what you'll see is this represents sort of my thermostat sensor. It's going to wait until something gets dropped into its list. And the minute that I do something like run this command again, put something in the list, what you'll see is over on the right there, that command unblocked and return what was there. So we've now got a queue-like data structure. There's other ways I could have done this with Redis. I could have done Redis pub/sub if I don't want to store these data values more persistently in Redis, or I could have used a stream again. But what I wanted was a data structure for this that acts like a queue. So if we do ln some list, it cleans up after itself in this case. So popping something off of the list really gets rid of it, whereas in Redis streams, consuming something from the list keeps it there because there might be other consumers. This is going to be a one-to-one. It's going to be instructions just for this particular temperature sensor. So what we're going to do now is add something to the list whenever we get to 10 over temperature counts, and we are then going to hopefully switch to MicroPython and be able to control the sensor with it. So when we get over temp count reset to 0, so look, we want to reset the over temperature count, and that's what we've got code for. And what else do we want to do now? We want to tell the thermostat what temperature to display, and to turn on the fan for a period of time. So we are going to do something like await client.lpush, and we need a key name there, so we'll worry about that in a minute. And then we need I think we can just get away with a single one. We'll see. We might just put it in array. Okay, I'm going to send in a JSON object. We can send in any sort of structure in here. So this could just be a string. It could be something that's comma separated. Whatever we want it to be, as long as the thing at the other end of the queue can understand it. So I'm going to use JSON. I'm going to keep the key names terse. And I actually need one of these. So temperature, I want to set to the, what do we call it? I think we just call it temperature. Set it to whatever the temperature is in the room. And then we want to send a key called fan. And these are going to need to be in quotes. Like that, and we'll say if you get this, turn the fan on for like 3 seconds or something like that. So okay, so if it's over temperature, we're going to say turn the fan on for 3 seconds, and then basically we're going to have a feedback loop that the other temperature sensor in the room will figure out if that's gone down. Maybe it's across the room from the fan or something, and it'll feed it back through the stream, and then we have this loop going on. So this should be what we need, hopefully. And what we need here is a key name. So let's see how we're making key names. I've got a prefix here. So if we do copy that, and where was I? I was here somewhere. Here we go. So key prefix, colon, and we'll call this thermostats, and we'll use whatever the room number is. We got the room number around somewhere, room ID. There's only one thermostat in the room, so we'll call it the room ID. So we'll start pushing things into a queue that says run the fan for a certain amount of time and display the temperature. So hopefully if we then run this, what we should see, this extra terminal, is either it crashes or something happens. Those are the kind of two things that could happen. Okay, so it's off doing things. It's not actually warm enough in the room at this point in the data set, though, so that's interesting. It's warming up, though, so it might hit the trigger point at some point. Or what we could do is temporarily lower the trigger so that we actually can test this data flow out. So let's do that. Let's say 23. Run that and see what happens. Okay, so over temp count went above 10 there as well. How is that happening? Interesting. So what have we got here? Over temp count is 15. That's interesting. Did we actually create a list? I don't think we did, no. So what is going on here? So my over temperature count. So rather than mess with the data, I'm just going to change the thing here. Run the consumer. Okay, that's better. So now it's resetting that. So it went through 10 things that were too hot, according to our new definition of what too hot is. And it reset the counter. And the question now is, did we? Yes, we have this new set of keys here. So thermostat 214. And we've got a couple of entries in there, and it's basically telling it, hey, here's the temperature, settle down the temperature by turning the fan on. So we've got a JSON document that looks fairly valid that says temperature 24.3 and fan for 3 seconds. Okay, so that seems good. So what I'm going to do now is a couple of things. I'm going to change this temperature back to, what was it, 25, I think we wanted here. And I'm going to leave that as is. That looks okay. And I am then going to clear out our stream data, because we've probably got quite a lot in here now, because I actually left that Raspberry Pi running. So yeah, we've now got 773 entries, which is quite a lot. So let us first up remove this. So I'm going to delete this. Well, I'm going to turn this Pi off first. So I've stopped our producer by unplugging it. So no new entries will appear in here. I'm going to delete this entire stream because we can reproduce it just by running the producer again. So we don't need that for the minute. What we do need now is something that talks to this list. So here. So we need something running on a Pi Pico that talks to this list. And what it needs to do is basically process this list, display the temperature, and turn the fan on for that amount of time. And then when you put it all together, we'll have a system whereby the producer Pi with the with the temperature humidity sensor and the light sensor on it is pushing entries into a stream. The node code is reading those and populating this list, or list per room of rooms that are over temperature. And then something is working this list going, oh, I need to display what the temperature is and run the fan for this much. So the the device that's doing this has no intelligence as to the wider purpose of the system. It doesn't know what the trigger point for the temperature is. That's controlled automatically in the cloud. It doesn't know how long to turn its fan on. It doesn't know why it's being told to do that. It just does what it's told. So hopefully we can now write some code that takes this list and does something with it. So what I need to do for that is, first of all, let's come out of the Node code and let's store it in GitHub. Now writes instructions to list for thermostat. That's what it does now. Okay, so we've banked that. And what we need to do now is, let's see, we've got this split by Node and MicroPython at the minute. The MicroPython code's actually the producer code, so the temperature humidity sensor. What I want to do is go in there for a second and make a bit of a change. So this code we've looked at before. It basically connects to my Wi-Fi using some secrets. It connects to the sensors that are attached to the Pi. It connects to Redis. And then it sits in a while true loop, and it doesn't add or add an entry to a stream every so often. It sleeps for 2 seconds, and it pushes these values in. So we've had this running quite quickly all the way throughout this project because we just wanted a good stream of data, and we wanted something to look at and get excited about, and it's quite interactive. If we're going to turn the fan on for like every 10th one of these readings that's over temperature, if we're going to turn the fan on for 3 seconds, then 10 of these readings takes like 20 seconds. So we probably need to slow this down a little bit. So I'm just going to make it 4 seconds to sleep. So just so it runs a little bit slower. And what I need to do to flash the code onto that is connect this Pi here up to the USB cable on my machine. And what we should see when that happens is that it connects, Visual Studio Code finds it, and it starts running the current code. And then we can flash the new code to it and verify that it's running a little bit slower. So here we go. The VS Code's found a board. I'm going to Control-C that, stop it running the current code and creating a new stream in Redis and all of that. And what I'm going to do is do upload project. This Pico W Go extension is fantastic for working with these devices. So it should have done that. There we go. It's connecting to my Wi-Fi. It's rebooted. And hopefully we'll start to see it putting data back in the stream, but a little bit slower. Here we go. So there's our first data there. If I switch to Redis Insight, I didn't have that stream key before. I should now have that stream key again now. And if we auto refresh, what we should see is it's a little bit slower. Everything's turning up like with a 4 second gap. And we're currently at 24 degrees. Now, what I was going to try and do was hit my trigger point later when we want to send this by holding my hand over the temperature sensor. And let's see if it heats it up. Slowly, 24.4. Hopefully we can hit 25 with just my hand. 24.7. 25.1. Okay, so that kind of proves we can do it. Right, so we'll let go of that. I've unplugged it, which will stop that data flow. But that's now got a slightly slower version of the code on it. So let's just bank that again. So we bank that, and what we need to do is create another sort of MicroPython project for this this other sensor, the one that is over here, that has the motor and the display on it. So the way that these work is there's no sort of package management or anything from MicroPython. So what I'm going to do is just make a copy of this whole folder with the Redis client in it and some other stuff that we're using, and maybe delete things that we're not using on this sensor, because every byte counts on these little devices. So what I'm now going to do is come out of here and do something like let's call it thermostat component, and then I can't spell thermostat. There we go. And then what do I want to do? See what we've got in there. So I want let's see, I want all the Python files actually. So we've created some files in here. I know I don't want DHT11 because that's the library for the temperature and humidity sensor. We don't have that connected to this device that we're going to be working with, so I don't need that. And let's have a look here. Okay, so we've got the code that we have for the temperature humidity sensor. A lot of this is boilerplate that we're going to reuse. It's things like connecting to the network sensor. We're not going to connect to temperature humidity or the light sensor because we don't have those. We do have other things, or connect to, we'll call this devices. We do have other things. We do want to connect to Redis. We've got the secrets for that still. That's great. We don't want to do that, and we don't want to do that, and we don't want to do that. And we don't really want to do any of that. So all this is going to be new code. Do something. So what we need to do as well is tell the Pico W extension that this folder is a Pico W project. So what we do with that is, I've actually got it here looking at my tasks. This creates a tiny file in the folder that then tells that extension that this is a MicroPython project that we want to run on one of these boards. So we could do something like print hello and then kind.sleep 5, save that. And then what I'm going to do now is connect up this second device here, and hopefully we can push the code to that, and we can just see in the REPL or the console down the bottom that it will run and do what we told it to. So we just check that this device is successfully running MicroPython, plug it in there. What we do now is connect. So we're connected. We've got a REPL on this little device. We don't really want that. We want to run our code. So what I'm going to do is upload the project to it. It's resetting the board. And let's see what happens. Absolutely nothing. That's interesting. What is going on there then? We've got a bad import in our code, so it's just basically crashed it. That is probably what's going on. So let's try that again. Upload the project, resetting the board, and hopefully it doesn't just come back to the REPL this time. There we go. So it's now running our code. It's printing hello, and every so many seconds, it's going to print hello again. So we verified that we can connect to this other board and that we can run code with it. So that's good. So now what we need to do is actually do something different. So we need to set up the display. We need to set up the motor, and then down here what we need to do instead of this is Redis list for this sensor. And we then need to, well, we'll just output the what we've got on there for now and see what happens. So the command to read from the list is brpop. So we need a brpop command. So we've got R as the Redis client on here. So we need to do r.brpop, and the way this works is it's all lowercase, and then we need key name, and then we need how long we are going to wait in seconds or block for in case there's nothing there. So we'll say 5 seconds in this case. And what we get back is something from the list. So we'll get r.brpop. Our key is, let's see, Pico project thermostats 214. Let's just hard code that for now. We'll tidy it up later. Thermostats 214. It's thermostats plural. Yeah, it is. That's inconsistent. I said thermostats and room. Okay, I'll fix that at a later time because I like to use singular or plurals consistently. But for now, we'll run with this. So we're saying we want to pop something off of that list, and the way that this works is a couple of things could happen. We could time out, or we could get nothing back. I've tried this client sort of off stream, and I've found that sometimes you get an exception, and sometimes you get a null item back. So we need to cope with both of these situations. So I'm going to move this into an exception handling block. So we're going to say try that, and then we're going to say except Redis timeout is an exception that the client throws. So we're then going to say this was empty, nothing to do. And we're also going to cover the case where when I'm parsing the data in this list, I'm going to try and parse it to JSON, and I want it to be somewhat resilient and not crash the sensor, because if it crashes the sensor, you need to pull power out and restart it. So if we send something that's not JSON or bad JSON inside that list and I try and parse it out, I need to do value error, which is what JSON.parse is going to throw later, and say something like invalid message. So we don't care about that message. If the message doesn't contain what we expect, we're just going to throw it away. So we've got list item here. And then, as I say, I did some trying out with this client off stream. And what I saw was that it sometimes does the timeout and it sometimes returns null. So what we need to do is check for that. So if we've got a list item, we've got something to do. Otherwise, we don't have anything to do. And I think there's a little peculiarity of this client that you either get one or both of these situations sometimes. So yes. And if there is something to do, what we want to do is get that payload out, and we're going to assume it's JSON. So let's see what we can do about that. I need to import JSON, I guess. I'm going to do something with that. But first off, let's just put the list item. Okay, so I don't see any red on here, so that's good. So also you'll notice this is like a while true loop. I don't necessarily need a sleep in here because the block here is going to do that for me. So I don't have to sleep in this loop. I don't need an explicit time.sleep. So we've got that. We've got our excuse me, list with 2 values. So hopefully when we do something with this, it'll pull those values off and just print them. And it'll run that on the device. So let us try that out. So let's do upload project here. I'm uploading the project. And let's see what happens. What I found is sometimes, I think streaming doesn't help with this, that the connection can be a bit slow. So, okay, list is empty, nothing to do. What I think's happened is it's probably processed those values off of the list. Let's see, whilst we weren't looking. No. So Pico project thermostats 214. So we've got a list called Pico project thermostats 214. Let's just check that I am doing this correctly. So I've got items in my list. Yep, still got items in my list. So what is going on? So we're connected to Redis. Check the Redis list for this sensor. Is none. Yep. This might sound crazy, but I'm just going to reset this. And reconnect. Let's see what happens. List was still empty, nothing to do. That is very confusing. So what we should be doing is processing things out of the list. So let's just put an invalid message on there as well. And what we should see when I do this is that's not appeared. What is happening here? Pico project thermostats 214. Did the Pi pop it off? Okay, interesting. It started. Started to pull things off the list. Have I got a... Let's see what the length of that list is. None. Ah, okay, it's gone away. So yeah, that's an old copy of the list. So let's see if I've got some commands. Okay, so if I do this, I push a thing into the list and I have the Pi output out there. There we go. What we should see is that something gets pushed into the list. And we're not always getting the values back. This is very confusing. Pico project thermostats 214. Okay, for some reason, this is not actually working as I expected, which is strange. Have I got, yeah, I've got Redis timeout imported, so that's okay. Let's just change this to the non-blocking version for a minute. So if we change this to the non-blocking version, we are going to then need to sleep for a while. So let's see what happens when we run that. So off we go, we're running our code. List was empty, nothing to do. Let me just double check that I'm like literally using the right key name. Here. Okay, off it goes. It's connecting to Wi-Fi, so it's rebooted. It's read from the list. It's read from the list again. I think I might have had some sort of weird state issue going on with the Pi and what code it was really running. Okay, so it seems to now be pulling things from the list. I am a little confused what happened there, but as expected, the list has gone away. So we're pulling data from the list. What we need to do now is, let's just stop that. It should work fine with the blocking command as well, but I'm going to leave it with the rpop and the sleep, which is essentially the same sort of thing. So this will fail fast if nothing's available in Redis, and it will sleep for 5 seconds and it will try again. So what we need to do is, instead of printing this list item, we now need to actually get some data out of it. So what I'm going to do here is turn it into a dict through JSON. So let's try parsing the JSON, and this is where things could go wrong, and I could end up in this value error if there's junk data in my payload. But I'm in control of the payload, so there shouldn't be. But you know, belt and braces will make sure, because this device would crash, and if we put it out in a room somewhere, we'd have to then go and power cycle it, which is a bit annoying. So there's no operating system underneath here to do that sort of thing for us. So what we're going to do is we'll still print it out for good measure, and then we will get the payload from it, and I'll need JSON.load from a string, I think. Yep, string. And what I need is list item, and let's see what that looks like. Have we got any? It's just string. Okay. So payload is JSON.loads list item, and then we can print out some things from this, and we can say temperature is whatever payload of T is, and that's in Celsius. And then we can say fan, and then we can do payload. I think I called it F. What was in here? Yep, F. So that's like the fan duration. That's how long we want to run the fan for. So let's do that and see if we can successfully parse out those values. So I've not really found a great way of debugging these boards other than just to, you know, try a few things at a time and see what happens. If you got any ideas on how to debug these with Visual Studio Code, I would be very interested in those. So, right, we're in the list empty, nothing to do situation. So let's go down to CLI here and push something valid into the list and see what happens. This is still insisting the list is empty. I'm beginning to wonder if there's some like behavior with this client and lists. Because if I do, oh, I'm pushing to some list. That's not going to help, is it? Let's push to Pico project, thermostats 214. Right, push to that. So let's see if anything happens now. Yep, we got our data. Okay, so it helps if you push to the right key. There's a good learning point. So we got a fan, and this sample data array got some other stuff in there. I don't really care about that. We're not going to use that because our node code's not doing it. So, okay, so we've got a temperature and we've got a fan. So what we need to do now is display the temperature on the screen and turn the fan on for that many seconds. So to do that, we kind of need to learn how this fan and the screen works. And the good thing about this Grove kit is this kit from a company called Seed Studios is they provide the kit, the shield here, and all the sensors, and they provide MicroPython projects for all of them. So if we scroll down here, there's sort of different sensors and different projects. And there's one down here that uses the sensors we've got. So here's the temperature humidity that we used on the app producer. And here is the temperature humidity again. Let's keep going down. We'll eventually find the one that we need. Here we go. So we've got this thing. We've got the 16 by 2 LCD. We want to display something on there. And we've also got the motor. So for the LCD, I've plugged it into the right thing on the shield that they want it plugged into so that their code should work. And then it looks like, okay, we need to import something. And they give us a Python file for that. So we'll get that in a minute. So let's import that into our code. Import that. We don't have that file yet, so it's going to error. So let's create that file. Again, there's no package management here, so I need to kind of like put things in the project. So we'll do lcd1602.py. And the contents of that looks like, the way that they do this is, I would expect this goes to their GitHub or GitLab or their source control. Yeah, it does. So this is the file that's the driver for that display. It's hopefully fairly short. Yep, we'll just copy that and literally drop it in a project right here. So save that. And we've now got an LCD 1602. So let's figure out what we have to do with it. Okay. Oh, here we go. They've got this thing called D. So that's setting up a display, and they've got an I2C. So we need I2C and pin from machine by the looks of it. So machine is like a MicroPython library for abstracting hardware away. So we're already using a couple of things there, or one thing there for one of the other sensors. We're now using 3 things, or we'll need 3 things. And so that looks like it sets up a connection to the display, and then this D gives us the display, hopefully with the higher level interface in that class that we just imported. So let's set up the display. Okay, and I'd like to call it something a bit nicer than D, so we'll call it display. Hopefully we should have a display set up, and then while we get down here, we can now display the temperature on the screen. How do we do that? So let's see. So they call theirs D. So d.home, d.print something. And yeah, we can do that with an F string. And then, oh, it looks like it's cursor based. So we only need to just show one line of things for this demo. So let's copy this. So I guess that sends the cursor to home, like display.home, like a 0, 0 position. I think it was display.print. Yep. And we can do, we can just reuse this for now. And is there anything else? Like, do we need to call this show or anything? Doesn't look like it. Looks like print actually just does that. Okay. So that might be our display handled. And then we need to turn the fan on for however long. Right. So let's see, just check everything's okay, because we're adding quite a lot of code here. We've got a whole new file. So if I do upload project now, we should add that new file, reset the board. Hopefully we'll start to see something come out of this. Reconnect. Definitely running a little bit sluggish. This possibly could be because of all the streaming stuff that's going on in this Mac, running the fan quite a lot. Okay, so that didn't want to reconnect. So I'm just going to pull the display out, pull the power out and put it back on again. But you can see on the secondary screen that our display has started to do something here. So, okay, we're back in Visual Studio Code. The list was empty, nothing to do. I've got a display that's woken up now. I don't know if you see that. It's very bright. It's got nothing on it at the moment. So hopefully, let's see if we put something into the list. Hey, there we go. Temperature 23.2. So we put something into the list. It parsed it out. It displayed it on the display. And we're now showing somebody what their current room temperature is, essentially. So what we then need to do is, if the fan duration is greater than 0, we need to go ahead and turn the fan on for that many seconds. So let's see if we can figure that out. So I'm going to stop this from running here. And okay, so we need to turn the fan on. So let's again have a look at what Seed have got for fan projects. So I don't see the fan in that one. It is, here it is. Go Grove Mini Fan. So Grove Mini Fan connected D16 on the base shield. I already did that, so it knows where to find it. And let's see what we do with pin 16. So they're saying configure pin 16 as an output pin and call it mini fun. I guess they mean mini fan. So we'll borrow that. And that looks like our fan setup code. So somewhere here, we do that. Oops. And we won't call it the motor. We'll call it the fan. And we'll call it fan. Okay, so fan becomes an output pin, and then what do we do with it? Back to the code here. So they've got a servo and other stuff connected in this project. We're not using that. We're looking for uses of mini fan. Okay, so dot value 0. What else? Dot value 1. So let's say, I'm guessing dot value 0 is going to be off and dot value 1 is going to be on. So try that. So what we need is fan duration equals payload F, which could be a number of seconds, and then we need fan.value to 1. Actually, that's so fan duration is greater than 0, turn it on, and just go to sleep for however long, and then turn it off again, I guess. Otherwise, let's maybe, well, no, we don't need to. Okay, so let's try that. So we're saying if fan duration is greater than 0, turn it on and sleep for that long, and then go again. So try uploading the project, and hopefully this goes smoothly. It's connecting to the Wi-Fi. Okay, list was empty, nothing to do. List is empty. Our temperature display's gone back to nothing. It hasn't received any data yet. This is our fan. Not a lot going on there. So let's swap back to Redis Insight and create a value there. And okay, 23.2 fan 0. So we don't need the fan. So it respected that. We didn't turn the fan on. So let's change the data here and say fan 1, and list D thing was, I was playing around with this before stream with like, do we want a duration and a fan on or off separately? So I had like F being on or off and D being the duration, and then realized that we don't really need that. So if I do fan 3 here, then hopefully, let's see. We've got 23.2 and fan 3, and nothing happened. So why did nothing happen? There's a couple of reasons why that could have happened. So we could have the fan not connected. We got the temperature message. We got 23.2. You can see that there. But we didn't get anything happening with our motor. So let's just interactively try and debug this. So one of the things here is we can do the REPL stuff. So let's do here's my fan. So I need from machine import pin, and let's try fan equals pin 16 pin comma out, and do fan.value 1, and off it goes. So we have a fan, fan.value 0, and it's off. So that seems like we have the code right. So we have the fan set up there. We have a fan duration. We have a fan.value. Let's just check that we're actually trying to do this. Here we go, connecting to Wi-Fi. This was empty, nothing to do. Let's put something in the list. Ah, it worked. It went on for like 3 seconds. That's weird. So all I've done is added a added a print statement. So I kind of wonder if that's there's some timing thing going on. There we go. Fan is on, fan is off. So we attempted to cool it down. So the idea of the project is that we create a loop now that if I turn on the temperature sensor, it will push things, and the node code decides whether it's too hot and how long to run this fan for. And then this here, the fan and thermostat sensor runs, or thermostat display runs the fan accordingly and displays the current temperature. So we could give this a go. So we leave this running. There's nothing going on with this at the minute. It's just checking in with Redis every 5 seconds to be like, do I need to do anything? Do I need to do anything? Let's see what we've got here. We've got our data stream of 12 entries here, where it is eventually going to go above the 25. So I don't need to turn on the temperature humidity sensor to create more of these. We've got a good data path that will basically show it eventually goes above 25.6, but it needs to be above there for like 10 things, doesn't it? So let's delete that. So let's start from scratch. So I've got that. I've got, this is where my consumer's up to in the stream. We'll delete that so it starts from the start. And what we're going to do now then is possibly somewhat ambitiously start our stream consumer. So our stream consumer is going to sit here and have nothing to do for the minute. Okay, no new stream entries. So this is listening for things on the Redis list. Nothing happening there because this is the thing that will put them in there, and it's not doing that yet because there's no temperatures being created. So if I then go ahead and plug in the temperature pi, we've got all of our components running for the first time together then. So connect that up and let's see if it starts putting data into the stream. So we'll see that appear in here, and we'd see it in Insight as well if we want to look at it there, but let's just wait a minute and see what happens. So is my second Pi also going to connect to my Wi-Fi and start putting things in? Not yet, it's not. Just checking that we've got power here. It should have booted up by now. I do wonder if sort of behind me here, if the Wi-Fi connection is good for these tiny little devices. Yep, there we go. So it started booting up. It's going to generate data. And as we can see, nothing's happening in the list because we're not at the over temperature value yet. So what I need to do is stimulate the temperature to be hot by holding this in the background with my hand. And hopefully, this is precarious, holding this. Let's see if we can get this over 25 and see if we can get that over temp count to 10 and then trigger a, hey, you should cool down, and tell the other sensor to turn on the motor. So we're now at 1 over temperature count. So I've got to sit here for a few seconds and let this happen. This is either the grand finale where it all works or it all falls flat on its face. Basically, those are the two outcomes we're looking at here. So we've got a Raspberry Pi Pico W pushing stuff into a Redis stream in MicroPython. That's in the cloud. We've got Node code that's looking at it and putting data into JSON documents. And then it's hopefully about to put something into a Redis list that another Raspberry Pi Pico over here on camera 2 below me will pick up on and turn on its motor for a few seconds to try and cool the room down, which obviously won't happen for real. So let's see. There it goes. So what we did there was a complete end-to-end test. I'm generating real data from this thing. I'm causing it to be very hot by using my hand. And we're now at over temperature count 4. So it's had 5 consecutive readings where it's over 25. So that Redis JSON document's getting updated to count that. We've got Redis search going on in here. We could search over these things and find rooms that are getting towards being over temp. And then when it hits 10 here, it's going to put something into a Redis list. And then my other Pi over here is both going to display the temperature it was sent and turn the fan on. So there's a little delay while it polls. There it goes. Run the fan for 3 seconds, turn it off. Then if I let go of this, hopefully it will cool down. And what you'll see is it's going to take a little while to cool down, so it might trigger itself again, is that it settles into a state where it's not doing this anymore. So the Pi here that's currently, the last temperature it got sent was, that's very bright, 29.2 Celsius. By the time we finish this stream, hopefully it will have cooled down enough on its own, because I'm not holding it anymore, that it won't keep triggering the fan. But I think it's about to trigger the fan again. Yep, there it goes. So it's triggered the fan again. We're still over temperature, but we are cooling down. We're sort of hitting 28.5 and so on. So yeah, that was a little bit messy, but we got there in the end. So we've got this whole distributed system, and the thing that's holding it all together in the cloud is Redis, using streams and lists and JSON documents. And we have the search capability, but we're not using it per se, because we didn't build an interface for that. So that was kind of it for this project. It's going to trigger the fan again in a moment, so stick around and watch that, because why not? Turns out there might be timing issues in this, so putting that little print command in helped. I'm not sure what the deal with that is, but it's working reliably enough now. And we're going to take a little while for that temperature sensor to drop back down below the 25 degrees. So I won't wait for that. I'll stop the components so that we don't keep running this fan. And I'll stop this one running on the Pi, and I'll pull the power out of the temperature sensor there. So that is kind of it. I think that project was reasonably successful. We sort of had a bit of scratching heads there, but we got there in the end. So if you are interested in this sort of stuff, then please check out our Discord here. We have a IoT Internet of Things channel, and I'm always interested in what you're doing or what you're interested in seeing me doing on this stream. This is kind of the end of this project now. So if you're watching this, get hold of me on there. And if you've got any ideas as to what you might want to see here, we would love to hear them. I'm going to be back later on today on Discord. So rather than on Twitch or YouTube, we have a series called Office Hours for Redis University. So if you've got any questions about any of the Redis University courses, please come along. I'll be along with, I think it's Justin and Suze today in Discord. It's pretty relaxed. We'll just be hanging out. So just tap us if you want to talk, and we can do video or audio or desktop sharing or just text chat, whatever you're comfortable with. And yeah, that's about it for today. So end of a project, quite a complicated one. I'll finish updating that and write up the rest of the README so that if people are interested in how it works, I can't imagine you have a need for a project that specifically does this. But if you're looking at microservices or IoT devices and you want to use Redis as a communications hub, yeah, we looked at streams, lists, JSON, and search. So quite a lot of options there. But yeah, that's everything. So I might see you on later today, and I'll see you tomorrow for This Week in Discord back here on YouTube and Twitch. Thanks very much, everybody. Bye.